Good day, ladies and gentlemen. I hope we are well. We are back again with the lesson on Newton' second law of motion, and then today we'll be looking at when two objects are on the inclined plane, and then they are connected by a light inextensible string. Uh, Before we get down to this Newton problem, would like to say now thank you very much for people who've been liking our videos and then sharing our videos. Please don't stop. There's more to learn on this channel as we go about. There's going to be a lot of physical sciences content that is going to be learned. So please share the channel with your friends. Like those videos and then keeps those likes coming. Let's without any waste of time get down to this problem, ladies and gentlemen. Please watch the previous video that we did on Newton's second law, whereby now we did only one object on an inclined plane. As discussed yesterday, we said now we are going to look at a complex problem based now on this Newton's second law, where an object is on an inclined plane. So in this case, we are going to look at two objects that are on an inclined plane, and these two objects are connected by a light inextensible string. So let's, ladies and gentlemen, without any waste of time, hit the ground running and see what does this problem have for us in store. So it says here a block of a mass 2 kg is connected to another block of mass 5 kg by a light inextensible string. Ladies and gentlemen, as you remember, when we say the string is light and inextensible, it says to us the string does not stretch, meaning that the tension that will be connecting the 2 kg block with the 5 kg block, you'll agree with me that the tension will be the same for both the blocks, because it is given to us here that the string is inextensible, it does not stretch. And then the statement further goes on to say, there at an angle of 30 degrees to the horizontal. The 30 degrees to the horizontal, they are now just talking about this angle that this the surface makes. And then by a means of a constant force parallel to the plane, as shown in the diagram, a means of a constant 40 Newton force parallel. And then they say the magnitude of the kinetic frictional force between the surface and the 5 kg block is 80 newtons. And then it says the coefficient of kinetic friction between the 2 kg and the surface is 0.39. They gave us here now the coefficient of friction. Ladies and gentlemen, from the statement that is given here, I can say now I have this force of 40 newtons that is pulling these two objects up the incline there, but the 40 newton force is only applied to the 2 kg block. It is the one that is going to make the 2 kg block to move up the incline. But the 5 kg block, what is it that is going to make the 5 kg block to move up the incline? It's now this tension force that we find here in the string that is connecting the 2 kg block. And then they further tell us that the kinetic frictional force, so we can conclude to say now this surface here, this is a rough surface, this is a rough surface. It means now there is friction there, and then we are given here the frictional force between the 5 kg block and the surface is 8 newtons. And then for the 2 kg block, they gave us now the coefficient of kinetic frictional force. Ladies and gentlemen, let's, without any waste of time, look now at the questions that they are going to ask. But as you all know, before I can go and look at these questions, ladies and gentlemen, I must then come up with now a free body diagram. A free body diagram for what? For these two blocks. I have two objects, meaning that I'm going to have two free body diagrams there. But as you can see here, the examiner, there's no way that the examiner asked me to draw a free body diagram. So if the examiner did not ask me to draw a free body diagram, I will then draw a free body diagram with components. You agree? For I will say for the 2 kg, for the 2 kg block, ladies and gentlemen, there, let me draw a free body diagram with components for the 2 kg. So you'll all agree with me that if I have an incline, I need to make a dotted line there, showing me now the inclined plane there, and then I will have a dot there, and then because it's on the surface, I will have now my normal force there. I will have my normal force, and then if I have my normal force there, there is a force that is acting upwards there, and then that force is a 40 Newton force, and then this will now be the F applied, or you can just say it's a 40 Newton force. But here I also have now the tension, ladies and gentlemen. Remember, in the previous video, we discussed that this 5 kg block, it's going to now apply a force on the 2 kg block. It's going to try and pull the 2 kg block downwards. So the tension in the 2 kg block will now be going downwards. I will have my tension there, which will now be tension. And then I was told by the examiner that there is a frictional force. So I will have frictional force going down there, opposing the motion. So this will now be a frictional force, Fk or Ff, ladies and gentlemen. Let me make a big dot here so that it can accommodate all my forces. And then remember, we said I am drawing a free body diagram with components. But let's draw the one without components for the 2 kg. So without components, you know that I will have now a force of gravity there acting downwards, and then this now will be Fg. This free body diagram, it's a free body diagram without components, ladies and gentlemen, for the 2 kg block. If the examiner was to ask me to draw a free body diagram for the 2 kg block, I will then have these forces. How many? 1, 2, 3, 4, 5. And then I will have my 5 marks there, and then I will then go home smiley. And then, ladies and gentlemen, let's now look at the 5 kg block. Remember, we are still drawing free body diagrams with components. I mean, without components. So I will then have my incline again there, and then on that incline of mine, I will have a dot there, and then there is a force that is causing this 5 kg block, ladies and gentlemen, to go upwards. And then you'll agree with me that that is the tension force. So tension force in this case must go upwards. So this will be my tension there. And then also I will have now my normal force. My normal force has to be perpendicular to the incline there. And then I will also now have my GFG there that is acting downwards. And then what else do I have? I have the frictional force, and then the frictional force, you'll agree with me that it will oppose the motion, Fk there or Ff. This, ladies and gentlemen, if the examiner was to ask me to draw a free body diagram. I will draw a free body diagram like that, the one without components. And then for me to answer these following questions, ladies and gentlemen, I will then need a free body diagram with components, because a free body diagram with components is the one that is going to show me all the forces acting on the object. So I will have my incline there again, and then here I will have a big dot so that I can accommodate all my forces there. So you'll agree with me that we'll still have the 40 Newton force going up, 40 Newton force going up, and then I will still have my normal force that is perpendicular to the surface. As you can see there, it's perpendicular to the surface. And then I will still have my frictional force. I will still have my frictional force and the tension force there. So I will then say here, let it be now the tension force, and then here let it be my frictional force, Fk there. And then remember we said we'll then break this Fg into its component, the parallel component and the perpendicular component. And then we agreed that the perpendicular component of Fg must now go at an angle of 180 degrees with the normal force. And then you'll agree with me that here I will have my Fg perpendicular, and then Fg perpendicular cannot go alone. It needs now to go with what? With Fg parallel there. So I will have now my Fg parallel. So can you see now this free body diagram? It doesn't tell me that there is now a force of gravity that is acting parallel to the surface there, that is now going to be acting downwards. So this free body diagram is the free body diagram for the exam, but this free body diagram is the free body diagram that I draw for myself in order for me to visualize all the forces that are acting on an object. And then for this a 5 kg block, I will still do the same. I will have a big dot there so that I can accommodate all my forces, and then you'll agree with me that I will still have my tension there, and then I will have my normal force that is acting perpendicular, and then I will have my frictional force there, and then we are breaking this Fg into its components. And then when I break into its component, I will have now my Fg parallel. Ladies and gentlemen, Fg parallel always now goes at an angle of 180 degrees with the normal force. It is now acting now on a straight line with the normal force. And then when I have Fg parallel, it says to me that I also now have to have the Fg parallel. And then these are my free body diagram. And then there's something we discussed in the previous video there, that when I'm working with an inclined plane, there is something that I must always now remember. I must always now remember this analogy that says pass peg. And you'll agree with me that pass peg now helps me to say now the parallel component I must use sine. Which parallel component? Fg. I must use the sine of theta. And then the perpendicular component, I must now use what? Cos of theta. So this perspective of ours, ladies and gentlemen, comes in handy when I now solve problems of an inclined plane. So with these free body diagrams, ladies and gentlemen, it is safe to say now I can go now and answer answer the questions there. So let's have a look at the first question. The first question says to us now, calculate the magnitude. They only want now the what? The magnitude of what? Of the kinetic frictional force between the 2 kg and the surface. And then they give us 3 marks there. And then you'll agree with me that with 3 marks, it's not a lot of work. Let's see, this will be number 1. Let's look at that 2 kg block. The 2 kg block, I was now given the what? The coefficient of kinetic friction. And ladies and gentlemen, every time you are now given this coefficient of kinetic friction, the first formula that must come into your mind is this one of Fk equals to mu k multiplied by the normal force. This formula, ladies and gentlemen, must always come into your mind when you are given the coefficient of a kinetic frictional force or static frictional force. How do I see that I'm given the coefficient of kinetic friction or the coefficient of friction? We said that now the coefficient of friction, it doesn't have a unit. So when I'm giving a value there without a unit, I must know that it is now representing my coefficient of friction there. So this is the formula that must come into your mind every time you are given a coefficient of friction. So it then says to me, I am looking for the kinetic frictional force. I do have the kinetic frictional force. And then the question comes to say, do I have the normal force? In the statement, did they give me the normal force? You'll agree with me that in the statement, there's no way that they gave us the normal force. But do I have information that I can use to calculate the normal force? Yes, definitely. You have information that you can use to find the normal force. Look, we said now, ladies and gentlemen, when I'm looking at the normal force, I will go to my free body diagram, the one with components, to see where do I find my normal force. And then you'll agree that we find our normal force in this plane right there. But our object is now moving in this plane, up the incline. It is not moving in this direction. So if it is not moving in this direction, you'll agree with me that the net force in this direction will be equals to 0. What do we mean by that? We are simply saying now, if the normal force plus, let's say normal force is positive plus negative Fg parallel, they must give us 0. The sum of these, they must give us 0 because the object is not moving in that direction. It's only moving in that plane there. So if it is not moving in this direction there, then the sum of the forces in this direction must then give me a 0. And then when I solve them there, I will see that my normal force is equals to the Fg parallel. So we are saying when we have an object on an incline and it is not pulled at an angle or whatsoever, the normal force will be equals to Fg parallel. And then it says to me now, where I see my normal force, I can substitute my Fg parallel. Where? In this equation that we talked about. So we'll then say coefficient of K is equals to Fg parallel. And then I know my Fg parallel. My Fg parallel, we talked about it yesterday, that Fg parallel is equals to mg parallel. I mean Fg perpendicular, ladies and gentlemen, sorry about that. Fg perpendicular. Fg perpendicular, we must use what? the cos there. So it's going to be cos of theta, and then this will then allow me to find the what, the coefficient of, and the magnitude of the frictional force. I will then have to substitute my coefficient there, and then the mass, it is now 2, and then multiply by the gravitational acceleration there, and then the cos of the angle there, which is 30 degrees, and then this will be equals to Fk. And then when we punch that into our calculators, we'll then have 0.39 multiplied by 2, 9.8 cos of 30 degrees, and then this will give me a magnitude of friction that is 6,198,187, and then therefore the frictional force there, it equals to 6,2 when you round it off to 2 decimal place newtons, and then that is that. So the key thing now to understand here is now that when I want to find the kinetic frictional force, here's the formula that I'm going to use. But now the trick now comes where now you have to find the normal force. So in this instant, where now you have an object on an incline, its normal force will then be equals to the Fg perpendicular there. And then we know that Fg perpendicular is equals to mg cos of theta. And then I will find now my magnitude of kinetic frictional force is 6,22 newtons there. I hope you are happy, ladies and gentlemen. And then it says now, if you are happy with that question, we can even now go further to answer the last question. The last question here, ladies and gentlemen, the last question then says, calculate the tension in the string connecting the two blocks. And then here the examiner says, for 6 marks, go and calculate that tension there. And then for us to calculate the tension there, ladies and gentlemen, I will bring now a new page here, because you'll agree with me that for us to calculate this tension here, we'll then need now a simultaneous equation. And then in that simultaneous equation there, we'll then need a lot of space. And then I will just now show my free body diagrams there, my free body diagrams, because those are the ones that are going to help me to calculate this tension of ours. So it says number 2 there. When we want the tension in the string here, ladies and gentlemen, it says to me that I must now make an equation for the 2 kg block, to say for the 2 kg block, and then remember it is now we apply now Newton's second law. So Newton's second law says F net is equals to ma. For me to be able to find the tension here, I must apply Newton's second law to the 2 kg block and also to the 5 kg block there. So it says to me that the F net is equals to ma there. And then you remember, ladies and gentlemen, that we agreed that where the object is going, that direction must now be positive, and then the one that is in opposite direction must be negative there. And then also here, this 5 kg will move up, so this side must be positive and then this side must be negative. So let's apply Newton's second law of motion to the 2 kg object there. So what are the forces that is acting here? I will say this 40 Newton is my F applied, which is positive, plus how much? Plus the negative Fk plus negative tension plus negative Fg parallel there is equals to ME. Can I now clean this equation of mine here, ladies and gentlemen? Yes, I can do that. I can say I have my F applied minus Fk minus tension minus Fg parallel. Fg parallel, remember we said parallel is sine, but we have Fg there, and we know that Fg is equals to mg. Then it will now be sine of theta equals to MA. And then I can substitute every information that I have. I have the applied force, which is 40 newtons minus the Fk. Remember, we just found the Fk here. We just found the Fk. This was the Fk that we found. So the reason why I wrote this in full is that I knew that I was going to use it somewhere. So I must use the full magnitude there. 40 minus 6,619898187. And then I'm left now with what? With the tension. Tension minus mg, the 2 into 9,8 sine of 30 degrees is equals to 2. Do I have the acceleration here? No, I was not given the acceleration, so I will keep it as SA there. And then I will then clean this equation by now taking all my known values to say 40 minus 6,619898187 minus this minus 2 into negative 9,8 sine of 30 degrees. And then it says to me here, this is 23,5801,0181 minus tension is equals to 2A. And then you'll agree with me that here, when I reach this stage, I must then make the tension the subject of the formula. Then it will then be 23,5801,18 minus, I will then bring this to the side, minus 2A is equals to tension there. And then this, I will then call it my equation number 1. Can I apply that to this 5 kg Newton? Remember, I said I will apply Newton's second law to this object and also now to this object. So let's quickly do that. To say now for the 5 kg, F net is equals to ME. And then when I go and look at that forces that are acting on that object, remember I must look at these forces because the object is moving in this direction. So I must look at those forces. I must start with the positive one, which says now it is my tension plus my negative Fk plus my negative Fg parallel is equals to ME. Can I clean this equation? Yes, I can. It's going to be tension minus Fk minus Fg parallel, ladies and gentlemen. Fg parallel is very, very important. I want to emphasize this point. If I used this free body diagram here, I will not see that there is a parallel component of this force that is acting now downwards. Ladies and gentlemen, when you want to do calculations, you must draw a free body diagram. A free body diagram with components. With components, so that I can see now there is another force here, which is FG parallel. And then FG parallel, ladies and gentlemen, always now acts down the slope. Always acts down the slope. If the slope is like this, FG parallel will act downwards. If the slope is like this, FG parallel will act downwards. So I hope you got that. So FG parallel, we know that it's equals to mg sine of theta is equals to ma. Perspec, parallel component is sine. There it's sine there. And then I am looking for tension, and then FK I was given in the statement. If you can remember, it was given to me as 8 newtons. So I will then say it's 8 newtons minus the mass, it's 5, gravitational acceleration, and then sine of theta is equals to mass 5. And I don't have the acceleration. You remember that if two objects are connected by a string together, they will have the same acceleration. So if I don't have the acceleration here, it then says to me I will not have the acceleration there. So when I punch this into my calculator, remember this 8 is negative here, so I will put the negative there. Negative 8 minus 5 into 9,8 sine of 30. So it says to me that this is tension minus 32,5 is equals to 5a. Ladies and gentlemen, please, when you substitute there, make sure that now you substitute everything as it is there. Everything as it is there. So we found now that our tension there, we must make it positive there, and then the subject of the formula to say tension is equals to 5a plus 32,5, and then that will then be now my tension for the 5 kg block. So this will now be my equation number 2. And then remember, when you get to this stage, ladies and gentlemen, this is where now I say tension for the 2 kg is equals to the tension for the 5 kg. And then what is the tension for the 2 kg? The tension for the 2 kg is there. It's 23,5801 0.118 minus 2a is equals to the tension for the 5 kg. Tension for the 5 kg is equals to 5a plus 32,5. So that is the tension there. And then I will then do what? I will then transpose. So I will have now 23,5801 minus 32,5 is equals to 5a plus 2 there, a. Then I will have that, and then I will then subtract here to say 23,5801 minus 32,5. Then this will give me now the negative 8,919,899 equals to this is 5a plus 2a. Then this will now give me 7a. Then I will then divide both sides there by a there, by 7, I mean, to get a, and then divide by 7. It says to me my acceleration is negative 2,7 2,74271,281, and then you'll agree with me that this negative here gives me the direction. So acceleration will then be equals to 1,27 meters per second squared, where it must now go downwards. It must now then go downwards. But someone will ask, can I get a negative acceleration? Yes, you can get a negative acceleration. What it means is that now, can you see this guy who's applying a force? It's going now up the incline. He's going up the incline. And then what this negative acceleration says, he says to me that when the blocks were here at the starting point, when the guy is still going up, can you see now the slope there is increasing? When the guy was still going up, the velocity of these blocks were now decreasing. And then if the velocity is decreasing as you go upwards, we are saying now the acceleration, the objects are accelerating in the negative direction there, and the negative direction was where? Was now downwards. Hence we say now here the acceleration is 1,2 meters downwards. It says now the velocity of these blocks here is greater than the velocity of these blocks when they get at this point. It shows me that the final velocity is less than the initial velocity. And when is that, you'll agree with me that you'll get a negative acceleration. So this is the acceleration, but the examiner asked for what? For the tension. So I will take whichever equation there to say tension. I will take number 2 to say tension is 5a, and then what is the acceleration there? Here is the acceleration, negative 1,274271,286 plus 32,5, and then when I punch that into the calculator, I'll have 5 into the answer plus 32,5, and then my tension there will now be 26,12 86435.7 newtons, and then that will now be the magnitude of the acceleration there. And then I hope you are happy with that, ladies and gentlemen. I hope you are happy with that. And then someone can say, hey, let me take this acceleration here and put it in equation 1 and see whether it will now give me the same answer. It will then be 23,580101018 minus 2 into this acceleration, negative 1,274271,286, and then it then says to us now that the tensions are the same. So it simply says now our answer is correct there, ladies and gentlemen. Thank you very much for joining us in this lesson of ours. Please, if you like the video, hit the like button there, and also tell your friends to subscribe to the channel, and then they must share these videos of ours. And then with that being said, ladies and gentlemen, thank you very much for joining us here. Have a great day.